Hi, good night, people. Well, tonight we have an invite from China. It's Feynman from China. So he's going to talk about how to use KubeSphere. He has a very practical example using OpenEBL, and will be really nice to have Feynman here this night. Well, because he's in China, it's the morning there. So, well, we are in different time zones. So, welcome to Feynman. If you want to introduce yourself.
Yeah, thanks, Sergio. And this is Feynman. I come from Beijing, China. I have been working at the cloud native area for almost 4 years. Now I'm a senior community manager at QingCloud, a public cloud provider in China. And at the same time, I'm also the CNCF ambassador. So my major responsibility is, focus on the advocacy and outreach. So today, in this talk, I'm gonna demonstrate and help you to understand the fundamentals of Kubernetes Service Discovery and our open source projects, KubeSphere and OpenELB. Yeah.
That was a really nice introduction. So yeah, you can continue with that.
Okay, it's my turn, right? So I will continue to get started with my presentation. Let me see if you can see my desktop. I will share it. Okay, as you can see from our poster, in today's talk, I will bring a session about how to learn Kubernetes Service Discovery in practice with KubeSphere and OpenELB. Okay, as I introduced earlier, my name is Feynman Zhou, and my current career is around operate and maintain an open source community. And I also did some work around the cloud native foundations and some cloud native projects. You can find my skills and my interests in my personal website, and it has some the technical topics around Kubernetes, Linux, Fluentbit, DevOps, and serverless. Okay, so before we dive into the Kubernetes service discovery mechanism, I will ask a question. So have you guys know how Kubernetes exposes service outside the cluster? Actually, we have 4 typical methods to expose a service outside the cluster. So imagine you want to expose your applications outside the cluster, and you want to make it available for your customers. So you might have 4 typical methods in your Kubernetes cluster. So the most common way you might use it every day, that is NodePort. And we have 3 other ways, that is LoadBalancer, Ingress, and ClusterIP. So at the beginning of this session, I'm gonna walk you through each one of those service exposure methods. So let's first focus on the service. So before we dive into the service discovery mechanism. So what is Kubernetes service? As you can see from this graph, if you
I
want
think that
to
your screen is freeze. Maybe the presentation is still loading.
It's still loading?
Yeah, it looks like that.
Ah, sorry
Yeah,
about
right
that.
now. Yeah, that's
Is
it.
it okay?
Yeah, I can see it.
Okay, so let's continue it. If you want to expose your deployment or your workload to outside, and you want your customer to access it, so you might gonna create a service and proxy your service request to your backend port. So sometimes we're gonna have multiple ports, so we need a service to proxy your the customer request to those ports. Generally speaking, Kubernetes service connects a set of pods to an abstracted service name and IP address. So why we need a Kubernetes service? I think the typical reason is that each pod has its own IP address, but the pods are destroyed frequently. That means their pod IP are not fixed. So the IP will be changed if Kubernetes recreate a new pod. So that means we cannot tell our users you can access the pod IP directly. So in production or in our test environment, we always use Kubernetes service to expose and proxy the request to our backend deployment or workloads. The first and the foremost reason is that service has the stable IP address for users to access. And the second reason is that, as you can see from this topology, when your request comes out the cluster to this service, so you will find the service has load balancing requests to a set of pods. And finally, I think the service can expose them within or outside the cluster. So this is the basic scenario of Kubernetes service. Okay, so let's jump into the second concept, which is Ingress. I think you might also use it in your daily work or your daily job, since it is also quite common used if you want to expose your service or applications with a fixed domain name or subdomain. I give an example of a Ingress at here, and you can inspect its YAML file at here. So as you can see that it has a kind for its service type that is Ingress. So you can also define the metadata and its specification, and you can also include your your subdomain or your domain as its rules. So imagine you have a website. The host is cave.example.com. So you want this domain can be accessed outside the cluster, and it can be accessed by your customers. So you can have a view of to this graph. Sorry about that. Let me close my Slack. Mute it. Okay. Let's go back to this Ingress topology. So as you can see, if there's a user access your domain, so the traffic is started from here. So it will go through the gateway. So the gateway is actually the Ingress controller implementation. So you can actually install your, for example, Nginx Ingress controller at here, and it will forward the request to the Ingress. So you can configure your domain name here. So the Ingress is such like a smart router or entry point into your cluster. So it will proxy and forward the customer request or with traffic to different backend service and pods. Apart from the NodePort and Ingress, from the service and Ingress, we have three typical methods to expose your Kubernetes service outside the cluster. And sometimes before we expose the services outside the cluster, so you might test and access the service within your cluster. So we might have ClusterIP, which is the default Kubernetes service. It gives you a service inside your cluster before you expose it to your customer. So you might do some test work with using the default ClusterIP to expose your service. And for example, if you have created a service without any other configuration, the default type is ClusterIP. So that means you can access this service via its service name or ClusterIP. So it will assign a static IP to this service. That means you can access it inside your cluster. And this is the traffic topology for request from the proxy to service within your cluster. Next, we will move to the NodePort and the load balancer. So before we deep dive into those concepts, I would like to give you a table which compares the different concepts and different user scenarios for each one. As we have introduced earlier for the ClusterIP, so it used to expose the service inside a cluster. So if you want to expose your services to external clients, so we might use the NodePort. NodePort is also very typical way to expose your service outside cluster, and it will open a fixed port on each worker node or each Kubernetes node itself, and it will redirect the traffic and receive on that port to underlying service. The limitation is that the port range is quite limited. We have only, you can see from this port range. That means if you have hundreds and thousands of microservices and you want to expose them, so you might find the NodePort is not enough to expose those large amount of microservices. So especially in some production environments, we might use LoadBalancer, which help us to expose the services through a dedicated load balancer and provision from the cloud infrastructure or our, the on-premises load balancer. Typically, in some cloud-based environments, for example, Amazon, AWS, Azure, and Google Cloud, you have, the cloud provider has the built-in load balancer for you to expose your services while the load balancer way. But sometimes we are running our Kubernetes cluster in data center or some air-gapped environment. So in that environment, you might not have your load balancer as the default option. So you might find some alternative to create your own load balancer plugin to expose your services as load balancer type of service. So in a word, you can regard ClusterIP as the smallest scope for exposing your service inside the cluster. So NodePort is the second way. So you can expose your services to outside your clients, but it has some limitations, and you cannot always use NodePort for your production environment. So my recommendation is be sure to use the type of load balancer to expose your service in your production environment. Okay, let's deep dive into the NodePort mechanism. As we have mentioned earlier, NodePort will open each port on each node, Kubernetes node. So as you can see from this graph, it has open port for 30,000 on each worker node. But it might bring some potential security issues since the traffic or the outside request can directly access your host without any authentication. So the type of service with NodePort, it is not recommended to expose your service in your production due to the limitations and secure problems. But it is quite convenient if you want to expose your service, and you just need to choose NodePort. It will assign a port to your service, and you can access it without any other configuration. Okay, let's continue to focus on the third way, load balancer. As we mentioned earlier, a load balancer service is a standard way to expose a service to the internet. So you can see from this topology, so when a request has come out and request to the load balancer, it will help you to proxy the traffic to the backend service and finally to their pods. So as you can see from a specification and the YAML file, so you just need to specify its type to load balancer and configure its specification to the pod and the traffic policy, and you might also add the annotations for your load balancer plugin, so everything will work for your load balancer type of service. Okay, in some real user scenario, we might have we might access our domain name, and it powered by the DNS cloud DNS provider, so it can map your domain name to the fixed IP address. This is a real use case that if you configure the Nginx Ingress controller for your Ingress and your services. Next up, we're gonna show you a live demo, which is used to create an application and help you to understand how the Kubernetes Ingress controller and the Ingress and service, how they work, and how we use them to expose our service outside cluster with KubeSphere and OpenELB. Before we jump into the demo, I'm gonna give you a brief introduction to KubeSphere. I remember I have demonstrated KubeSphere in my last session, but I still need to give a basic introduction about this project. KubeSphere is a distributed operating system which is used to manage cloud-native applications with Kubernetes as its kernel. So we can say an example for Linux kernel and Ubuntu, right? So Linux kernel and Ubuntu, the relationship between them for your use case is that you might always manage your Linux kernel and manipulate those Linux commands, while your Ubuntu desktop, you might have that Ubuntu desktop as your client or for your operating system. Actually, KubeSphere is a Kubernetes distribution, so you can imagine Kubernetes is its kernel. So this is the GitHub address for KubeSphere organization. So if you want to install it yourself, you can have more. You can jump into the official website, kubesphere.io. Okay. Generally speaking, KubeSphere provides a wide range of features among service mesh, CI/CD pipeline, application lifecycle management, observability, and security and authentication. Let me give you an interesting graph. For example, we always talk about the CNCF landscape. There are a lot of CNCF technologies, built on Kubernetes. For example, Fluentd and Fluentd Knative, Jenkins, Argo CD, Prometheus. So some guys are always asking, is that enough? Have you ever learning those technologies and provision your cluster? Actually, right now it is quite fortunate we have KubeSphere, and all of those technologies have been packaged in only one single control plane. So that means you can manage your applications to your infrastructure within a single control plane. That is, KubeSphere can powers your daily management and the maintenance work for your, the Kubernetes and applications, for running your Kubernetes and applications. Okay, so what is OpenELB? As I mentioned earlier, so in the cloud-based environment, for example, AWS, Azure, the cloud provider has the built-in load balancer for you to expose the type of load balancer in your environment. But if you are running your Kubernetes cluster in some air-gapped installation environment, or for example, in your data center, so you don't have the built-in load balancer plugin, but you want to expose your services with the type of load balancer. So that is OpenELB. The typical use case is that it can help you to expose them with load balancer type of service. So this is a typical use case for OpenELB, but it also have some features such as it has supported Layer 2 and BGP mode, and it also provides IP address pool management, and it also supports some edge environment, K3s and the KubeEdge. In the end of last year, OpenELB has been donated to CNCF as a CNCF sandbox project. So right now it has been released around 8 releases. So you can right now you can download it from GitHub. This project was originally created by our community, KubeSphere community, and which is designed for exposing the type of the load balancer type of services in bare metal, edge, and the virtualization environments. Okay, so we have a lot of adopters there. They help us to polish OpenELB project and help us to iterate this project. So if you are using OpenELB, let us know. So far, we have gained 930 GitHub stars, and we have around 20 contributors from 5 organizations. And it has also adopted by more than 30 companies in production. We have also presented this project in KubeCon China and CNCF webinar. So if you are interested in the previous presentations, you can check out them via these links. Let me briefly introduce why you need OpenELB. A lot of folks might asking comparison with OpenELB and MetaLB or other load balancer implementations. So I think, briefly speaking, OpenELB has the cloud native design. We can also say the Kubernetes native way to help you to install and expose your services, since all of those components are written in CRD. So you can use Kato to easily install it and manage it. And it has built-in HA support. That means it is recommended to run OpenELB with your services in production. Okay, I think for the typical reason, you can use OpenELB in some on-premises environment. For example, bare metal, edge, and virtualization. So they have no SDN capability, and it requires a router to help you to proxy the services from the switch to the Kubernetes services. Okay, right now we can focus on the OpenELB architecture. So as we mentioned earlier, all of those components are written in custom release definitions. So that means you have EIP, BGP config, and the BGP peer inside the OpenELB components. So when you install OpenELB, it will help you to proxy the services from outside, the router, and map the MAC address and MAC address from your worker node to your Kubernetes service. OpenELB uses GoBGP as its implementation, so that means it has integrates all of those features from GoBGP cookies, and you can also use it with the router and switch, which supports BGP protocol. As we mentioned before, OpenELB has supported 2 ways to expose your services. The most commonly used one is layer 2 mode. That means you can expose your services without the external switch. So this is a kind of software router solution for you to expose your service. As you can see from this graph, so the OpenELB has sent the ARP packages to the router, and it helps you to match the the service IP to its MAC address for each node. So typically, it will proxy the request to only one work node. So if and OpenELB operates this kind of mode for active standby mode. That means if there's a failover for worker node 1, it will switch this request and the traffic to the second node. But there is a typical disadvantage if you are using layer 2, since there might be a interrupt for a while. It needs to switch your request from worker 1 to worker 2. So that means your service might be interrupted for a while in this period. As you can see from this graph, if the traffic is come out from the client machine, and it will request to the router, and then OpenELB will help you to handle those requests and map its ARP packages to the MAC address. So finally, the traffic will come into service. So you can, and in this way, you can expose your service with type of load balancer outside the cluster. So typically, if you want to run OpenELB in production use, I recommend you to use the BGP mode with the outside, the physical switch or the physical router. As you can see from this graph, the most different part is that BGP mode provides built-in high availability mechanism for running OpenELB itself and expose services outside the cluster. As you can see from the beginning of OpenELB, at first it will help you to match the BGP rules to the service IP address. So that means the interrupt will not exist when each node is failover or is broken. So that means it provides the high availability natural. So you don't need to mind that there is an interrupt if there is any failover. So the BGP mode is quite critical for running your services in production. Okay, this is the principle of BGP mode with high availability support. So as you can see from this graph, so it has leaf node and the spine node, which helps the OpenELB to handle those requests and let them know where is the destination and how to handle those requests with the service and the client machine. Okay, I think the basic concepts is some kinds boring, but I would like to show you a live demo for running OpenELB on KubeSphere or Kubernetes. Okay. let's open. So if you want to install OpenELB in your personal environment, you might go to the official website. So you can go to the Get Started page. So it will help you to installation. So at first, you have 3 ways to install OpenELB in your personal environments. So the typical way to install OpenELB on Kubernetes is using YAML or using the Helm chart. That means you can install OpenELB with a single YAML and you can apply it, and it will running 2 deployments and help you to set up all of those manifests and resources inside your cluster. You can also use Helm chart to install OpenELB, but in today's session, I'm gonna use a KubeSphere as a content platform to help you visually install OpenELB in your Kubernetes cluster. Okay, there is also a step-by-step guide which helps you to install OpenELB on Kubernetes and KubeSphere. I have a live demo for KubeSphere, so let's open it. Okay, give me 1 second. All right, we have logged into the KubeSphere content platform, and we have seen the landing page for KubeSphere. So let's jump into the workspace, which is the multi-tenancy mechanism inside KubeSphere. So you can create your own workspace, and then you can create your project and DevOps project inside a workspace. So this is the basic you need inside KubeSphere. So we have already created a demo workspace, so we can jump into it. And then we can import a Helm repo for the OpenELB. So right now we have already imported a OpenELB repo. So if you want to import your own Helm repo, you can click here and fill out the address for the OpenELB or other Helm address. Okay, so after we imported a Helm repo, so we can create a new project and you can jump into it and to see what's happening inside the project. I would like to introduce the concept project in KubeSphere. So basically, this is the Kubernetes namespace, which is used to isolate the resources from different namespaces or different tenants. I have already created a new demo project or with a Kubernetes namespace inside my cluster. So right now, we can install it while the application Helm repo. So we can choose it. So we can choose the OpenELB and click install it, and click next and click install. Since the time is limited in this session, I have already provisioned the OpenELB deployment and application in my environment. So as we can see, it has set up the workloads and services inside this application. So if you follow my methods to install it via KubeSphere, so it will help you to set up all of those stuffs automatically. Okay, let's go through this documentation. After that, we have set up the OpenELB application. So next, we can try to use it for our test or development environments. So typically, we might use the layer 2 mode for our development and testing use case. Since it is quite convenient if you don't have your physical switch, it can help you to leverage the software LoadBalancer solution to expose your services with ease. Okay, so it has some prerequisites for use this kind of mode, but since my cluster has missed the requirements, so we can skip step 1 and step 2. So if you have multiple NICs in your workload, you might execute this step. So right now, we can create a kind of EIP resource to help you create a range, or we can say a IP pool for your EIP object or for your EIP pool. So after this step, you can OpenELB can help you to assign the fixed IP address to your services automatically. So you can regard this EIP object as an EIP pool. Okay, since this is a CRD, so we can copy it and create a EIP object in our cluster. Okay, this is a web kubectl inside KubeSphere. So as we have already copied this YAML file in our cluster, so you can see the EIP YAML file. So we can cat it. You can view this YAML file. Okay, pay attention. We have already defined the IP address, and it has a fixed range for this IP pool. So that means our services and our IP will be assigned from this pool. Okay, so next we can use kubectl to apply these resources. EIP YAML. Wait for a while. I think it will create those EIP object in your Kubernetes cluster. Okay, it hints that these resources have been created. As I have already created this object before, so that hints this resources is unchanged. Okay, after we created an EIP object, so next we can create an application which used OpenELB to help you assign the LoadBalancer IP to your Ingress or your services. Okay, typically you can create your own deployment and services via kubectl. If you are a UI guy, so you can use KubeSphere Web Console to help you to set up an application or your deployments quickly. So since the time is limit, we need to we can deploy a sample application which has built-in in KubeSphere. So this is a book info application with the deployment, service, and the ingress. So we can use the built-in application as our demo application. So we can close the application governance and give its name as booking for OpenELB. And click next. And here, as you can see that it has automatically generated a domain name for our ingress. So we can save it and create it. Since we have already created this resource and applications before, so I think the name, it has conflict. Okay, it doesn't matter. We can use the existing applications for this demo. if you want to run your own application, so you can follow this way to deploy a sample application built in KubeSphere. Let's jump into the book info application. So this is a type of resources that defined by KubeSphere, which is application. Actually, it has composed different kinds of resources, the rules for Kubernetes Ingress and services and workloads. So as you can see, all of those services and deployments are running. So that means you can access it while your Ingress or services. So right now, we can jump into the service list. You can see that the application have set up 4 services, and it has also a root. Actually, the root is the Kubernetes Ingress, which helps you to proxy the traffic to different Kubernetes services. Okay, as we have already configured the Ingress and the load balancer for our Ingress controller, so it has automatically assigned the gateway address. We can also regard it as the load balancer IP address. So we can open its YAML. So this is a kind of Ingress object. Okay, let me verify it via kubectl. Ingress demo project. As I mentioned earlier, we can configure the host domain name for each Ingress, which help you to expose your services with a fixed and easy to use domain name. So we have already configured the book info for your Ingress. So that means right now it can help you to proxy the traffic to this domain. So we can try to curl this domain name. It might require for a while, since this page might loading for a couple seconds. But I think if we ping this domain name, it should return normally. Okay. We can also give an example for services. For example, if we want to expose a service with the type of load balancer, you have 2 ways to expose them. So the first one is you can use kubectl, and you can also use the added YAML file, and you can update it and update the property from type ClusterIP to load balancer. I would like to give you an easy-to-use way to update it, since KubeSphere has provided the feature for you to update it from its web interface. So here, we just need to choose load balancer, and you don't need to do anything. Click OK to save it. So wait for a while. So right now, you will find that the OpenELB has assigned a new EIP address for this service. So you can find that we have this IP address that has assigned to this Kubernetes service. Okay. You can also find this IP address from here. So right now we can verify access this IP address to use this service. Okay, so at first we can use kubectl to verify it if this service has been assigned a fixed load balancer IP. Demo project. Well, we got it. So right now we can use the EIP address to access the product page. Let me verify it. We got it. We missed the service port for this kind of use case. So right now we can successfully access the landing page of the book info application. So we query it from this load balancer IP address. So typically you can access it in your browser. So if your internet has connection with your Kubernetes cluster. So I just use a demo application and OpenELB to expose my services outside the cluster. So if you want to run your own application, just try it on openelb.github.io. It is quite convenient and easy to use for you to running OpenELB inside your cluster. Okay, so you can see that for this actually you can access this IP address to verify stability. Hookinfo.com. I think it is still loading. It is, since this page might have a lot of HTML elements, so it might require time, but it works before this session. This is quite wild, but one thing I am quite sure is that we can ping this address and it has a normal return. We can ping this address, info.com. Yeah, it works fine, but the landing page cannot be loaded successfully. Let me check if we have configured the IP and host mapping in our host file. It exists. Okay, I think it might caused by the updated gateway address. Actually, we have already verified it from the Kubernetes service, and we can access it by our web kubectl. So I think this is a typical use case for OpenELB and type of load balancer. Okay, let's go back to our slide. Right now, we have successfully demonstrated how to install OpenELB on KubeSphere. KubeSphere provides a way for you to install anything, any kinds of Kubernetes and the cloud-native applications on your cluster. So it provides an easy-to-use web UI for you to manage and monitoring your resources. Going forward, we will integrate ELB in the built-in application store. So as you can find from the application store. So right now we have a lot of applications inside the application store. So in the next release, we will integrate OpenELB here, and you can only you just only need to click install application from, for example, from here, and you can install it while a couple of clicks. As when it comes to the future works and roadmap for OpenELB, so apart from integration with KubeSphere, we are going to provide some non-BGP protocol for OpenELB, and we are also planning to achieve the high availability in VIP mode based on KubeLive. That means you can use OpenELB as your Kubernetes cluster load balancer. That means if you want to install a highly available Kubernetes cluster, so you can have OpenELB as your cluster load balancer, not only for the service load balancer. Okay, so for that, and for other works, we're gonna focus on support IPv6 and the VIP group and more VIPs. And we might also provide a individual UI for OpenELB, which help you to easily manage EIP and IP pool with the individual web interface. And finally, we're gonna provide the Prometheus metrics for OpenELB, its components. That means you can monitor the OpenELB itself in your KubeSphere or Grafana dashboard. Okay, so actually we have did OpenELB presentation before. So this is the high frequent asked question from our user side. For example, if you want to expose your services, you can use OpenELB with type of load balancer. So you can expose your services with 80 or 443 port for an HTTPS use case. So in this use case, you can leverage OpenELB. So the second question is that if I have configured my OpenELB with the services, and I would like to expose my services with 443 port with HTTPS. So how to configure it? Actually, we have two ways to configure HTTPS accessibility. The first one is you can use the TLS mechanism. You can create your secret, and you can use this self-signed secret and the certificates inside the Kubernetes secret, and you can bind that secret with your Ingress, and you can configure your HTTPS at that Ingress. So it will help you to expose your services with the HTTPS. The third typical question is that most people are concerning about the comparison of OpenELB and MetaELB. MetaELB has been incubated for almost 5 or 6 years. It is somehow a mature project, but OpenELB is relatively young. So we have a English blog which used to introduce the differences between OpenELB and MetaELB. So I'm gonna tell you the typical differences between them. For example, OpenELB has been implemented as a Kubernetes native way. As we mentioned earlier, OpenELB advertises the rules and the traffic using GoBGP, which is a standard BGP implementation in the open source community. That means it has inherits all of those useful features from the GoBGP community. So there has been listed a lot of advantages and the use case from GoBGP. So I think these two parts are the typical differences between OpenELB and MetaELB. So if you want to learn more about their differences, I think you can install both of them and you can test it from your side. I could only give you an option which one is better. I think you can test it from your side and take a look at this blog. I think this is all for my demonstration. So if you have any question, let me know.
Yeah, if you have questions, you can post the question as a comment on YouTube. Maybe I think that there are already 2 questions here.
Mhm.
One question is, as far I can see, KubeSphere as well supported platform. Based on your experience, it's really stable for you?
You mean the project status?
I think that maybe the whole platform, I think the user experience, the tool is stable to use. I think that compared with Rancher or OpenShift, what is your
That's a
opinion?
good that's a good question. Um, there's a lot of alternatives for this area. Kubernetes container platform, or we say Kubernetes distribution. So Rancher and OpenShift has been existing in this market for I remember 7 or 8 years, right? So most of them know that project. KubeSphere is relatively young, but right now it has been open sourced and developed for almost 4 years. And right now we have a lot of users running KubeSphere in production environment. So as you can see from our official website, the landing page has shown a lot of use cases, and you can see that a lot of banks and the insurance institutes has running KubeSphere in their production cluster. And KubeSphere is also providing the built-in HA support with the built-in HA proxy for running an HA Kubernetes cluster. And last but not least, you can regard KubeSphere as a only Kubernetes application. So even KubeSphere is done, it will not affect your business and your applications. Yeah.
So
So
it's
I think
really transparent to adopt. I think it's not like using custom things like Rancher that it's like not a vendor locking, but there are some custom things that you depends on Rancher and that kind of things, as I see. Here's another question. Jorge
mhm.
Gutierrez from Nicaragua is asking if there is a way in KubeSphere to manage container images.
um, if you want to manage container images, you can install Harbor from KubeSphere application store, since KubeSphere is designed for manage containers and pods and every Kubernetes resources instead of the container images. There is a lot of container image registry which help you to manage the doc images or other Helm artifacts. So I think you can install Harbor on KubeSphere, and you can integrate Harbor with the KubeSphere container platform. Yeah.
Here's another question. Christian Castellano said, the KubeSphere dashboard remembers me the Lens dashboard. Are the tools
Lens.
for similar use cases?
Um, This is also the same question for the first one. I think this Lens is also a new alternative for users to running Kubernetes cluster and applications, especially for the multi-cluster use case. Um, I would say KubeSphere is typical design for the developers. That means you don't need to learn more concepts and fundamentals around Kubernetes itself. You don't let your developers to deep dive into what is demo set, what is the CRD. All of those concepts has been abstracted into a high level and easy to understand resources and staffs into KubeSphere. So we have project for Kubernetes namespace, and we have DevOps project for the Jenkins pipeline. Yeah. So from the high-level perspective, I think KubeSphere is designed for the developers and DevOps teams, since it provides features like DevOps, service mesh, and all of those features have been integrated and built in within a single control plane instead of a connector to different places. So you can install and manage all of those applications within a single product instead of running, for example, ELK, Grafana, and other applications on their own user interface. Yeah. For example, you can have your built-in the monitoring matrix from its monitoring page. It also gives you an infrastructure monitoring and the logging and auditing logs from a single control plane. That means you don't need to install and maintain your Kibana or Grafana dashboard. So you can have a monitoring and alerting. All of those are built in. Yeah. I think the design mechanism and product source are quite different from all of those alternatives. And I think KubeSphere is a little bit similar to OpenShift, since all of those features are built in and you don't need to install all of them by yourself. Is it much clearer? Hi there. Hi, Sergio. Is anything works fine?
Yeah, sorry, I was muted.
Okay.
Anna Isabel Kulahai has another question. A lot of students are watching this session. So she's asking like, why just Kubernetes and not another technology?
Sorry, could you rephrase this question?
Why just Kubernetes and why not another technology?
Kubernetes has been the de facto the container orchestration in this area for many years, and so we built on Kubernetes. We have also investigated Docker Swarm and Mesos before 4 years, but at that time we know that Kubernetes is already the king of this domain. And recently we also integrate and support another Kubernetes distribution, K3s and EKS distro and other the Kubernetes distribution. So that means KubeSphere can running on any kinds of Kubernetes distribution. It is a Kubernetes native application.
Interesting. Yeah, it's a really nice talk because, well, right now we are learning Kubernetes. We are looking how to get the things easier for the students. Could be really interesting to test KubeSphere with the students.
Actually, I just get started with my fundamentals of Kubernetes and all of those cloud native technologies from KubeSphere.
Really?
KubeSphere provides an intuitive way and a graphical web interface for you to quickly locate the issues and quickly query the Kubernetes services, and all of those stuffs inside the cluster. I think this might be much developer friendly for those Kubernetes newbies. You can inspect all of those logs, and for example, you can inspect the logs and events and the container logs. Yeah, this might help you to learn it very quickly, since you know the relationship between each resources from a single control plane.
Yeah, this part is pretty similar than GCP. It's like pretty similar the view for the logs and
Yeah,
right?
exactly.
So I don't know if the people that is watching has some last question for Feynman, another question, or I think that there are not more questions. So, well, Feynman, thank you very much for your presentation to contribute for the people that is learning Kubernetes. Alejandra Navarro says good vibes. uh, yeah, I
Thanks
don't know if
everyone
you
out
want.
there.
Yeah, I don't know if you want to say some final words for the people that is watching us, for the students, or something.
I think we have, we are not only open sourcing and maintaining KubeSphere. We also have a lot of, a lot have some other CNCF projects. OpenELB and Fluent Operator and Open Function. I think we have a lot of interesting solutions ranging from serverless, networking, and logging. Yeah. So you might have a look at those projects, and if you have any questions, reach out to us. You can also join us at KubeSphere Slack channel or CNCF Slack channel. We are always there.
Yeah, for sure. Yeah, so thank you very much, Feynman. I think that, well, personally, I have to test OpenELB with my Raspberry Pis. Just like
Yes.
I used to use Metal LB, to be honest. So I was like, really interesting. I didn't know about OpenELB. So could be really interesting to test this on the Raspberry Pis.
Yeah, thanks. Give us
Okay.
any feedback if you have.
Okay, so I think that we have to say goodbye. So thank you very much, Feynman, for all this night.
Yeah, thank you all. Have a nice evening.
Yeah, thank you. Bye.
Bye bye.